We'll be seeing about functions, which form one of the most interesting characteristic of any programming language. Functions are specifically written procedures or modules which performs certain task that you assign it to. So in R programming, the keyword used to create functions is R, is function, followed by two set brackets. Directive and are stored as R objects, just like anything else. In particular, they are objects of class function. So you have seen like multiple vectors and characters, integers being stored as objects in R programming, and in the same way, functions are also stored as objects of class function. So this is a common syntax. F, you are assigning a function to F function and the arguments that you are passing into, and these arguments are nothing but values, variables which you want to use inside the function, and inside the function you are doing something, and your closed loop. So this is your function syntax. And functions in R are first class objects, which means you can treat them much like any other R object. Importantly, functions, you can pass functions as arguments to other functions, and functions can be nested, same as your looping statements, so that you can define any number of functions within a function. The return value of a function is the last expression in the function body to be evaluated, which means you are giving a specific task to a function, let's say a function to add two numbers. You are passing an argument a comma b into that function, and the values, value computed inside the function a plus b, should be used, should be returned using the return statement, as you saw in the control structures. What are these function arguments? So like you have these named arguments, which potentially have like the default values. So the formal arguments are the arguments included in the function definition. Every function will have a definition which will say the number of arguments that get passed into, and the nature of arguments, like is it a character that is getting passed into, or integer, or it can be anything else. So the formal function returns a list of all the formal arguments of a function. Not every function call in R makes use of all the formal arguments. Function arguments can be missing, or it might have default values. Argument matching. So argument matching, it's like these functions arguments can be matched by position or by name. So the following calls to SD are all equivalent. Let's say like there is a function my data where R norm of 100. So you have SD of my data. So the my data is passed into the function SD as a vector. So SD of x equal to my data also you can assign, or you can pass directly as SD of my data. And the next is xd of x equal to my data, wherein you are assigning a name to my data, and sd of x equal to my data comma na dot rm equal to false. Same way you can send it vice versa, sd of na dot rm equal to false, x equal to my data. Again the same way you can pass without assigning my data equal to x, sd of na dot rm dot equal to false comma my data. So it is allowed in R programming to it is allowed in R programming to change the arguments position, but I would not recommend you to do that, because it will create more confusion while you are using the programming. So you can mix positional matching with matching by name. When an argument is matched by name, it is taken out of the argument list, and the remaining unnamed arguments are matched in the order that they are listed in the function definition. Args of LM function, it will give you the formula, data, subset, weights, any dot action, method equal to QR, model equal to true, x equal to false, y equal to false, QR equal to true, singular dot OK equal to true, contrast equal to null, offset, and those kind of things. So you are seeing two equivalents of the same function here. Lm of data equal to my data, y approximation x, model equal to false, 1 is to 100. Again, you are passing the same function, just switching the positions of the variables here, and both are exactly correct. Now, most of the time, named arguments are useful on the command line when you have a long argument list and you want to use the defaults for everything except for an argument near the end of the list. Named arguments also help if you can remember the name of the argument and not its position on the argument list. For example, you can go height and width if you are passing inside passing as arguments inside functions. You can just use keywords height comma width for getting those arguments, so that you can easily remember height means height, like a width means weight, same as that. So for example, plotting, you can use x comma y axis. If you are passing to the function, you can remember x equal to x and y equal to y, so you can easily remember what is what when you are passing the names as a function inside the function. So function arguments can also be partially matched, which is useful for interactive work. The order of operations when given an argument is: check for exact match of a named argument. So whenever you're named the argument, this is the order of processing. So whenever you're named, the names will be first taken into consideration, and check for a partial match. If there is like the variable name, using the variable name, they will look for a partial match, and based on that, others will be formed. And the last comes your positional match, where exactly it is called for x comma y or y comma x, those kind of things.